higher resolution displays like 4K screens are becoming more affordable, although they're still more expensive than their lower res counterparts, but the technologies in them are getting better as well. Most gaming consoles are designed to play on 4K TVs, and a lot of PCs are more powerful than consoles. So I've noticed a lot of people are wondering if it's finally the right time to move to gaming at 4K resolution. However, as you can see right here, the performance drops massively if you run a game at a higher resolution, especially going up to 4K resolution. So let's talk a little bit about gaming at 4K in 2024. Is this finally the right time? Is it still kind of stupid from a performance standpoint? Now we'll see that if you're gaming at a higher resolution, having a more powerful PC is certainly going to help you out, and Jawa.gg is the place you should look. If you follow the link in the pinned comment and or video description, I can even get you $10 off your first purchase if you use code OWEN10. Now, what's Jawa and why should you check them out? Well, they offer the best price to performance builds on the internet. They're quite confident in that statement. They're like, yep, we said it. Buy and sell with our community of real gamers for epic builds at unbeatable prices. And that's what you'll get at Jawa, the opportunity to buy and sell PC components as well as full systems. And you can find an awesome upgrade here. Again, you can check out individual components. You can check out happy customer testimonials. You can even get instant cash for your graphics card by taking the hassle out. Jawa will buy directly from you. But again, you can also look at listing things yourself. You can look at pre-built systems at a wide variety of pricing categories. And if you need help picking out your components, a lot of times it's awesome to get that one-on-one feedback from a knowledgeable community, and you'll find that there at their Discord community, which had over 10,000 members last time I checked in on it. Whole bunch of featured PCs, a lot of happy customers, and they even do monthly giveaways. And again, I can save you $10 off your first purchase using code OWEN10. Follow the link in the video description and or pinned comment, and huge thank you to Jawa for sponsoring today's video. Well, let's take a look at what's going on here. So first of all, a 1080p monitor has a little over 2 million pixels because it's 1920 by 1080. So multiply that and you get the number of pixels. A 1440p screen is 2560 times 1440, which is a little over 3.5 million pixels. And a 4K screen is 3840 times 2160, which is over 8 million pixels. And specifically, it's exactly 4 times the resolution of 1080p. So your graphics card, when you're playing at 4K resolution, is having to draw exactly 4 times the number of pixels when you're playing on a 4K screen as it is when you're playing on a 1080p screen. Now, interestingly though, game performance doesn't scale linearly with the pixel count. In other words, if it was 4 times more difficult to run a game at 4K resolution than 1080p, we would see 1/4 of the frame rate if you test the same GPU here. The test I'm looking at here is in Horizon Forbidden West on a 4060 Ti 16 gigabyte at very high settings. And we can see the actual numbers right here. So the 4K performance was 36 FPS, which is reaching 42%, so a little less than half, but definitely more than 1/4, more than 25% of the 1080p performance, which was reaching 85 frames per second. And the 1440p performance was reaching 74% of the performance of 1080p. So performance doesn't scale linearly with pixel count. So that helps a bit, but you can still see that the card's performance does absolutely tank. You're at less than half the performance. Another thing to understand is that the individual game that you're playing will scale differently depending on what how the game renders everything. So here's another example. This is Starfield at ultra settings. And you can see here, this is still on the 4060 Ti 16 gigabyte, that at 1080p resolution, we're getting 61 FPS. At 4K resolution, we're getting 30, so just about half. And 1440p is reaching 80% of the 1080p performance. So again, showing a little less than half the 1080p performance if we're playing at 4K resolution. And then if we jump ahead here a little bit in my tests, we will jump to another game. This is looking at Avatar Frontiers of Pandora, which is a big visual showcase game using the Snowdrop engine from Ubisoft, and this game also features some ray tracing. And here I'm actually noticing the worst 4K performance relative to the 1080p performance, dropping down to 39%, with 28 FPS at 4K versus 76 at 1080p. Now also, all of this was carefully selected to be on a GPU that wouldn't run into VRAM issues moving up to higher resolutions, where some cards would have the performance suffer even worse depending on the graphics settings being used if you're using the higher resolutions, because more VRAM buffer is required for those. However, all is not lost, because what we're looking at here is what if you used modern upscaling techniques? Because more and more games are starting to feature technologies like DLSS, FSR, and XeSS, which let you run a game internally rendered at a much lower than 4K resolution and actually provide an output image that is still similar to a 4K native output. Here we're looking at the Horizon Forbidden West testing with native 4K TAA versus 4K DLSS performance. Now I want to make sure you understand how low the internal resolution is on DLSS performance when you're doing a 4K output. It's 50% resolution scale per axis, which actually brings it down to internally rendering at 1920 by 1080. However, it doesn't get your performance back up to what it would have been at a native 1080p resolution, because the DLSS upscaling algorithm itself has a performance cost, and also not every part of what the game is doing is being reduced to a 1080p resolution. Some things are still done at the native resolution. But if we look at the performance boost here, we're seeing that the game rendered at DLSS performance versus the native 4K TAA boosts its performance by 75%, going from 36 FPS up to 63 FPS. And while many of you won't be on a 4K display to actually look at this footage, I am, and I can tell you that while 4K DLSS performance, especially in heavy motion and in some games more than others, does not resolve always at the same level of detail as a native 4K output, it does look massively more detailed than a 1080p output. By the way, pro tip when you're watching footage on a monitor, or especially like if you're on a phone right now, if you're looking at footage like this and you're like, I can't see the difference, you can pinch and zoom, and you can also set your YouTube to load the video at a 4K resolution, and phones can pinch and zoom, things like that if you want to look at the details. But this isn't really about a detailed image quality comparison. Just know that 4K DLSS performance doesn't look as good as native 4K, but it does look a lot more detailed than a 1080p or even a 1440p image. Now, again, different games will get different performance boosts, so why don't we take a look at that for a minute and take a look at some other tests. So here we're looking at Starfield, where on the left we again have 4K native TAA at the ultra settings. Again, all this testing so far is on the 4060 Ti 16GB GPU. I will look at some other GPUs and other rendering resolutions and things like that later into the video. But here we're also, again, on the right looking at 4K DLSS performance mode, so we're at a 1080p internal resolution. And we're seeing that the game is boosting performance by 70%. So a bit less, but in the same ballpark as to what we saw in Horizon Forbidden West. So we're going from a 30 FPS to a 51 FPS, which can be very playable. And here I'm also not looking at techniques like frame generation, which could smooth things out even further. Now, moving to Avatar Frontiers of Pandora, where at 4K native TAA, the performance is down below 30 FPS. We're at 28 frames per second. By enabling DLSS performance mode, we're seeing the 4060 Ti 16GB actually more than double the performance. So seeing a bigger boost here than we did on the other ones, going up to 61 FPS. And I think ray tracing in general is very helpful for... I mean, not very helpful, but how should I put it? Upscaling is very helpful in a ray tracing context, because I think you're tracing a lot of rays based on the pixel counts. That is something that scales very closely with the rendering resolution. Now, we're also going to look at some other things here, looking at like, what about 1440p versus like 4K upscaled, and upscaled 1440p versus upscaled 4K. But again, a lot of times I get some pushback from people when I talk about the upscaling techniques being used to, enable a higher resolution display, where they're like, but what if my game doesn't support it? And that's absolutely something to think about, is that while support has grown massively for upscaling techniques, not every game does support it. Now, most of the newer AAA games do support some combination of DLSS, FSR, and XeSS upscaling solutions. And many times it's older games that don't, but it's also older games that will be easier to run on current mid-range hardware at a native 4K resolution. So that's another thing to think about. I did look up like the list of the latest games supporting DLSS, and this list also has ray tracing and DLSS 3 frame generation. But if you look at the DLSS 2 column, that's the upscaling thing. And I started to scroll through this thing, but like the list is just ridiculous, and most of these have that check mark in the DLSS 2 column. So there's a large number of games that are supported here. But again, it's not every game. So that is certainly something to continue thinking about. But anyway, let's get back to this. So if you're still here thinking about what rendering resolution do you want to play at, another thing to consider is, okay, what about 1440p? So what I thought I'd take a look at is the performance between trying to run native 1440p versus DLSS performance at 4K. Once again, this testing is on the 4060 Ti 16GB. And here, this was very interesting. I'm getting literally identical average frame rates and only a 1 FPS difference in the 1% lows at 63 FPS between 4K DLSS performance, which again has an internal resolution of 1080p, so lower than 1440p native. But because it's outputting a 4K, to a 4K screen, you actually will get increased detail compared to the native 1440p display. So something to think about there. Again, I wanted to look at how this performs in other games, and Starfield saw similar results where the native 1440p display is running about the same as DLSS performance on the 4K display at 51 FPS versus 49. So, about the same performance, 4% lead for the DLSS performance figure. But let's go ahead and skip ahead and look at Avatar, which again was our ray tracing test. And here, I actually saw the 4K DLSS performance take a 17% lead over the native 1440p image. And again, in all of these cases, I did feel like you see more overall detail with the 4K output using DLSS performance versus just having 1440p, because you just are limited in the number of pixels you get off of 1440p versus the massive increase to pixels you get on the 4K display. But all of that is ignoring the fact that you can also use upscaling techniques on the 1440p display as well. So if you were already planning on using upscaling at 1440p, where I think a less aggressive setting would make sense, and honestly a less aggressive setting would make sense for 4K as well if you had more powerful hardware than what I was testing here. But here we're looking at DLSS quality on the 1440p screen versus DLSS performance on the 4K screen, and then looking at the performance numbers that we're getting here. And here in Horizon Forbidden West, we're seeing 83 FPS for 1440p DLSS quality versus 63 at 4K DLSS performance. That's a 32% performance advantage for the 4K display with upscaling. And if we move on to the Starfield test, we're seeing a 20% lead in performance for 1440p DLSS quality versus 4K DLSS performance. The numbers being, we can get a 61 FPS on 1440p DLSS quality, whereas we're only hitting 51 FPS at 4K DLSS performance. And if we go ahead and take a look at the Avatar testing, we're seeing a 31% lead for 1440p DLSS quality versus 4K DLSS performance. So even though 4K DLSS performance was running similarly to a native 1440p performance level, if you're already talking about using upscaling, it's only fair to talk about using it on both. And so it does look like if you're going to use DLSS quality on your 1440p screen, you would be getting 20 to 30% better performance than you would if using DLSS performance, which is the most aggressive upscale you'd probably want to use on that 4K display. So it's certainly more demanding to play at 4K than it is at 1440p, and obviously 1080p is the least demanding out of all of them. Now, if you're just What are we getting out of all of this? I think what I'm trying to show here is that 4K is way more accessible than it used to be due to upscaling technologies and monitor prices coming down, although they're still quite expensive. You still aren't as performant on a 4K display as you would be on a lower resolution display, especially if you're willing to use upscaling techniques on those lower resolution displays as well. And again, so far we've just looked at DLSS performance mode. So what type of hardware do I think you would need to maybe be comfortable trying to get into a 4K screen? Well, that really depends on what your goals are and how much upscaling you want to use. So for example, a little while back, I did a video on the RTX 3090, the previous generation flagship GPU, versus the RTX 4090, current generation flagship GPU, tested in the latest games at a variety of resolutions and graphic settings. And we can see here that a 3090 is handling an Unreal Engine 5 powerhouse like Lords of the Fallen at only about 30 FPS in the section of the game I was testing here. And the 4090 was still not playing at a 60 FPS average in this section here. However, again, if you are willing to use some upscaling, like if you use DLSS quality settings, then the 3090 is up a bit under 60 FPS and the 4090 is hitting 88 FPS average. So what I'm getting at here is even the most powerful and most expensive graphics card currently available isn't going to run every game even at 60 FPS if you're trying to avoid using upscaling at all. So my conclusion from that is basically if you plan on gaming at 4K, you really will be relying on upscaling techniques to get high frame rates if you're playing the most demanding AAA games. And that's just going to be the case. And you can also look at, performance level upscaling here where the 3090 jumps to 67 FPS and the 4090 jumps to 104 FPS. So you can choose the level upscaling you're comfortable with, and there's also frame generation techniques. So just be aware that that gaming at 4K resolution will generally require upscaling, even on extremely high-end GPUs, sometimes even the current most powerful one, if you're playing the latest, most demanding AAA games. That being said, if you do just accept the fact that you might be having to upscale, what sort of GPU level might get you a reasonable experience on a 4K display? Well, I have videos like testing the 4070 Super versus the 4070 Ti Super, and again, at a native 4K resolution in some of the most demanding new games, we're seeing 32 FPS and 42 FPS respectively. Probably not the way you're sorry, playing my own voice in the background there, sorry, from previous video. But anyway, if we go to 4K high settings with DLSS quality, we can see a card like the 4070 Ti Super jumping to 68 FPS and the 4070 Super hitting 55 FPS. So you can see that if you're willing to go to quality level upscaling, which at 4K resolution tends to look very good, if you're at this kind of 4070 Super and 4070 Ti Super tight performance level, you're probably going to be getting a decent experience with quality level upscaling. And you could, again, go more aggressive on upscaling as games get more demanding over time. You can also try kicking on frame generation, which smooths things out, although doesn't make the game more responsive. And then there's also, okay, what if you look at the AMD alternatives? Well, cards like the 7800 XT and the 7900 GRE, gaming at something like even Cyberpunk at ultra settings, they're not getting 60 FPS without upscaling, so cards like this would also probably be relying on upscaling. But if we go ahead and maybe turn down graphic settings, which is another way to go, we're getting close to 60 FPS here at 4K high. You can try kicking on FSR quality on the high baseline, and now we're up here over 80 FPS, right? So we can get to reasonable settings for cards of this caliber at 4K resolution. But again, you'd be gaming at much, much higher frame rates if you were playing at 1440p or 1080p instead. Also, keep in mind that different upscaling technologies have different quality levels, and while I do feel like quality level upscaling at 4K does look pretty good with FSR, it's very usable. If you start getting more aggressive, like starting getting down to the performance modes with FSR, it starts to break up a lot more than what we saw in the DLSS image. So just do be aware that if you're going with an AMD GPU, that you would be more probably want to go less aggressive on the upscaling settings. Although again, 4K with FSR quality, since it has a very high pixel count to work with, can look pretty good. So what sort of price range does that put us in if we're looking at this kind of class of hardware? Well, something like a 7800 XT, which again is not going to be running native 4K resolution amazingly, but could reach reduced settings with upscaling that might be reasonable. We're looking at almost $500 or so to get to that level of performance. If we're looking at something more like that 4070 Super, we're coming in, $570 at the low end. And that's a 12 gigabyte card, and at 4K you do want to be more conscious of VRAM. So if you wanted to go up to that 4070 Ti Super to go the NVIDIA route and get 16 gigabytes of VRAM, now you're closing in on almost $800. So I would say that gaming at 4K resolution, in conclusion here, is definitely more accessible than it has ever been. But that doesn't mean it's going to be something that makes sense for everybody. You're definitely going to be spending more money on graphics cards to get satisfactory performance if you're trying to play the latest games. And you will likely be relying on upscaling techniques, especially as time goes on, and especially the weaker your GPU is at the beginning, right? And again, we saw even cards like the 4090 can't always play games comfortably at a native 4K resolution. That being said, upscaling techniques are continuing to improve and being more available, and 4K monitor pricing is coming down. So I don't think everyone should avoid 4K resolution like the plague for gaming, like I may have advised 5 or 6 years ago, where it was just very difficult to get good performance on at any reasonable level in the latest games. Whereas nowadays, again, with upscaling techniques being more accessible and higher quality, it's no longer, I think, an avoid like the plague type of decision. However, I still think that personally, 1440p is going to be my most often recommended resolution, because I do think it looks significantly better than 1080p due to the higher pixel count, right? We're going up to over 3.5 million pixels instead of 2 million pixels. So you're getting a lot more information for your eyes to see on that screen, but you're not blowing out the pixel count to over 8 million pixels, which again, we've seen is just very difficult to do. So I really think 1440p displays are probably the sweet spot for a fairly mid-range to high-end gamer, you're kind of enthusiast. And I think 1080p still has its place for people who just want to play games on a budget and get as much performance out of the lowest end hardware that they possibly can for as long as possible. Although I did a recent video showing people that gaming at 1080p native resolution performs about the same as playing on a 1440p screen with DLSS quality, while getting all of those additional pixels of information for your eyes to see. So I do think that 1440p monitors are also starting to make a lot more sense versus 1080p monitors for people who are in a position and desiring to upgrade monitors right now. Because in the end, if you're on a setup that you're happy with, you don't have to just spend money for the sake of spending money. But if you're in a place where upgrading your setup, including maybe the monitor, or just your monitor, is something that you're considering, like I said, I would steer most people towards 1440p. And I would say you could consider 4K, but just be cautious about it due to just, like I said, 8 million pixels is a lot to ask of any GPU, but it's more accessible than it used to be. I hope you guys found this video useful and or interesting. And a huge thank you to viewers, subscribers, commenters, and especially channel members who click the join button down below to directly support the channel financially. That's absolutely huge. Massive thanks. And in return, you get membership badges on your comments. They're easier for me to find and reply to. Early access to some videos, like I'm planning on putting this one up early because I published a different video today on the main channel. So all of that is a huge thank you. Totally understand not everybody's in a position to support financially, and that is totally okay. Appreciate everybody. You're all beautiful people, and I hope all of you have an excellent day.